Hello everyone. So now we'll be practicing a few questions on refraction at curved surface. My name is Seshan Reddy. I'm a graduate from IIT Dhanbad. Let's quickly go into the problems. But before that, let's also revise the formula once. At a curved surface, okay, when light is incident on a curved surface, curved boundary between two transparent media, then what happens? Refraction takes place. Then we have a relation between the object formed, that is the object distance, the image distance, and the radius of curvature of that surface. And mu2, what is that? Refractive index in medium 2, and mu1 is refractive index in medium 1. Now it's very important that you have to recognize medium 1 and medium 2 properly. What is medium 1, everyone? What is medium 1? Medium 1 is the medium in which there is incident ray. I'll just say incident ray medium. What about medium 2? Obviously the other medium is medium 2, or you can say refracted ray medium. Okay, and obviously you have both type of surfaces, concave or convex. Everywhere it is applicable. Wherever you have a spherical surface, we say curved, but exactly speaking a spherical surface, then this formula is applicable. So refraction at a spherical surface, you can apply this formula. What the terms mean are given here. We discussed about that. So let's very quickly go into the problems. So we have one simple problem here. We have options also. Let's try solving it. An air bubble in glass, mu is equal to 1.5, refractive index of glass is 1.5, is situated at a distance 3 centimeter from a spherical surface of diameter 10 centimeter. So look at that. When diameter is given, yeah, in your mind you have to do the calculation. Diameter 10 centimeter, radius 5 centimeter. You have to be careful. Okay. So here 3 centimeter is what? The distance of the air bubble from the spherical surface. So that would be object distance. The distance from surface at which the image of bubble appears is. So we have to find the image distance. Everything is given. In fact, the image is also given to us. Look at the image. This is spherical surface. This is glass. Refractive index is 1.5. This here is the air bubble, that would be the object in our case. And the distance of air bubble from the spherical surface is how much? 3 centimeter. Right? And the second medium, this other surface, the refractive index is 1. So we have all the given information, and using this we have to find out the image distance. Let's proceed. First of all, what is given? Diameter is given as 10 centimeter. But we need radius. And again, radius also has a sign. It can be positive or it can be negative. Ultimately, what is radius? It is a distance of the center of curvature from the surface. Yes or no? So here if I look at this surface, where will the center be? To the left of the surface or to the right of the surface? Where will the center be? To the left of surface or to the right of surface? What do you think? Yeah? For that you have to imagine the circle. In fact, you can draw the circle. Right? If I draw a circle, the circle would be something like this. So center would be somewhere here, that is towards the left. Yes or no? That is towards left. And what does towards left mean? See, understand this. This is the object. Just a minute. This is the object. So how will the incident rays be like? The incident rays will be in this direction. So the incident rays are going in which direction? Along the principal axis. Along the principal axis they are going towards right, and what does that mean? That will mean that towards right is positive. In the direction of incident rays, it is positive. So towards right is positive, whereas in the opposite direction it will be negative. And the distances are measured from the surface, right? So if I keep that in mind, We already got that center would be somewhere here. Let's say center of curvature is here. So from the surface, if I measure the radius, the distance of the center, is it towards right or left? See, from the surface it is towards left, and left is negative. So you will take radius as negative. And what is the value? Diameter is given as 10 centimeter. Radius is half of diameter, so minus 10 by 2, minus 5 centimeter. So we got radius with proper sign. Now what about object distance u? What about object distance, everyone? Negative or positive? What do you think? Negative or positive? Yeah, it would be negative. Object distances are always negative. Whether it be the case of a spherical mirror, or in this case, or in the case of lens, that we will be learning, object distance is always negative. You can blindly take u is equal to minus, and the distance is given as 3 centimeter. You can even see why. See, from the surface, the object distance is towards left, and left in our case is negative. Right, so object distance always negative, blindly take it as negative. So we got radius, we got u. Then we need mu1, the refractive index of the first medium. Now what is the first medium? What is the first medium in this case? Glass or air? What is the first medium? See, look at this. If this is the object, the incident rays are in which medium? The incident rays are in glass. Refractive index 1.5. So mu1 will be equal to 1.5. And the refracted rays will be in the second medium, or the other medium, which is what? Air. So mu2 is equal to 1. So once you identify the information, the given information with proper sign, after that it is simple formula substitution. What is the formula? You have to remember mu2 by v minus mu1 by u is equal to mu2 minus mu1, both of them in the numerator, upon r is the radius. All that we have to do is substitute, solve, we'll get the answer. Yes, let me do the substitution in the next page. So the formula is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Mu2 we got it as 1. So 1, v we have to find out, we don't know. Minus mu1 is how much? How much? 1.5. Upon u, object distance always negative, but u is minus 3. So with brackets, please substitute with brackets so that there will be no confusion. You will not miss the sign. Is equal to, see, mu2 is 1, mu1 is 1.5. So order is necessary. So mu2 is 1 minus 1.5. It can come negative or it can come positive, does not matter, but the order is very, very, very important. Then what is r? R is minus 5 centimeter. You have taken all of them in centimeters, the object distance in centimeters, the radius in centimeters, so the image distance will also be in centimeters. You need not worry about that. But what you have to worry about is both radius and the object distance should be of same units. Generally they will be of same units, but you have to be careful. Then it's just solving part. Let us solve it. 1 by v. Then look at this. Minus by minus. What is that going to be? Minus divided by minus plus. 1 by v plus. Then 1.5 by 3. How much is that? 1.5 into 2 is equal to how much? 5 to the 10, 2, 1, 3, 30, 3.0. Not 30, 3.0. That is 3. Yes, so I can say 1.5 by 3 is 2. So it will be plus 1 by 2 is equal to 1 minus 1.5. How much? 1 minus 1.5, that will be minus 0.5 upon minus 5. Good. Again, you can further solve it. 1 by V plus 1 by 2 is equal to 0.5 by 5. What will that be? Minus minus cancel. That's fine. But 0.5 by 5. How much? This everyone you should be comfortable by now. 0.5 by 5. I'll multiply with 10. What is that? 0.5 into 10, 5. 5 by 10, 50. What is 5 by 50? Now it should be easy. You divide it with 5, you will get 1 by 10. Yes or no? So I'll use 1 by 10 here. Good. Simplified. Then take 1 by 2 to that side. Let me do it. 1 by V will be there. 1 by 2 will go to that side. Then it becomes subtraction. 1 by V will be equal to 1 by 10 minus 1 by 2. Then you have to take the LCM of denominators. 10 and 2. LCM will be 10. So 1 minus 2 into 5, right? So 1 minus 5 by 10. What is 1 minus 5? Minus 4. Minus 4 by 10. Now is this the answer? No. Because what did we get? We got 1 by V. But what do we need? We need V. We have to take the reciprocal, right? We have to take the reciprocal. So V will be equal to, if I do the reciprocal, it is minus 10 by 4. And what will the units be? Centimeters. What is minus 10 by 4? It is minus 2.5 centimeter. See, we got the image distance with proper sign. We got the image distance with proper sign. Understood? Simple. So the answer will be option A. So where is the image, by the way? Where is the image? See, object distance is 3 centimeters. So image would be somewhere here where the image distance is how much? 2.5 centimeter. Why towards left? Because of minus. Minus will show that it is in the negative direction. Negative is towards left. So towards left of the surface. 2.5 centimeter. Simple, straightforward question. Yes? Good. I'll go into another question, another similar question per se. A small object stuck on the surface of a glass. Now, this is an interesting question. You have to read that carefully. Stuck on the surface of a glass. Refractive index is given as 1.5. Okay, refractive index of glass. So stuck on the surface of a glass sphere of radius 10 centimeter, radius is given, is viewed from the diametrically opposite position. Find the distance of image from the center of the sphere. But think, sir, what is this question? Okay. I'll explain what the question is and then I'll give you some time to solve it. So let's say this is a sphere. Which sphere is it? This is a glass sphere. Now if the object is here, let's say there is a point object. See, a small object stuck on the surface of a glass, so it is on the surface of the glass, is viewed from the diametrically opposite position. That means there is someone here. That observer is watching it. So how will he watch it, or how will the rays go to him? First, these are the incident rays. Now they are incident on this boundary, the boundary between glass and air. For glass, the refractive index is given as 1.5. For air, the refractive index will be 1. Now the question is, what happens at the second surface? Right, obviously refraction takes place. Right, so see, you have all the information. You have the refractive index. You can get the object distance from the diagram. And the radius is given as 10 centimeter. I'll also write it down. Radius is given as 10 centimeter. Okay. Can you solve it now? Yes. So please solve it. I'll show you the question. I'll give you 1.5 minute of time, which is 90 seconds. Right, so please solve it. I know this is an interesting question. I will not call it tough, but interesting. Again, it's very simple by the way, but interesting. So please solve it. And then draw the image yourselves. Once again, draw the image. When you draw the image, you'll understand the situation, the scenario. What's exactly happening, you can imagine. Then you can easily solve it. "25 seconds more, everyone." "10 seconds more." 5, 4, 3, 2, 1. The time is up. Right, now let me solve it. I think the answer would be option A, but let me verify. I don't exactly remember. Let us solve it and then you will understand what is the value. Okay? Okay, so let's directly go into the figure. From the figure, we'll try to understand what's happening. I'll again explain. This here is the object. The incident rays will go in this way. I'm drawing two rays, obviously, but there can be any number of rays. And the observer is here. Refraction takes place. So this is a surface, yes or no? And this would act like the principal axis. So from this point, we have to measure what? We have to measure the distances. So let's first go into this. The center will be somewhere here. What is the positive direction here? See, the incident rays are going towards right. That means towards right is positive. And towards left will be negative. Towards right is positive, towards left is negative. That is the first point we have to decide. We decided that. Then we will go into the given information, but with proper sign. So given information. What is the radius here? The value of radius is given as 10 centimeter. Okay, this distance is 10 centimeter. That's fine. But what is the sign? What is the sign, everyone? That is the important point. See here. For the radius from the sphere, from the spherical surface where refraction takes place, in which direction are we going here? Towards the center, we are going towards left. And left is negative. So that means here, the radius will be negative. The value is 10 centimeter. So radius is equal to minus 10 centimeter. I told you, right? If you draw the image, everything will be simple. Then, what about the object distance, u? This is the object. From this point to this point, what will the distance be? It will be nothing but the diameter. And what is diameter? Twice the radius, 20 centimeter. And object distance is always negative. That means u is equal to minus 20 centimeter. So we got the radius. We got the object distance. Both of them done. But what is medium 1? Medium 1 is the medium in which there are incident rays. That would be glass, and refractive index is 1.5. So obviously the other medium will be medium 2. So here mu 1 is equal to 1.5 and mu 2 is equal to 1. Simple. So once you draw the diagram, you'll get this. Once you get this information, you'll easily find the image distance. Right, as simple as that. So let me use the given information and let us solve it. So what is given here? Given information is this. Radius is given as minus 10 centimeter. Object distance is minus 20 centimeter. Mu1 is 1.5. Mu2 is equal to 1. That is the given information, exactly same information. I just written it down here. Then let us solve it. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. What is mu2? Very careful, let me substitute. Mu2 is 1, so 1 by V minus mu1 is 1.5 upon U. What is U? U is minus 20, so with brackets minus 20 is equal to mu2 minus mu1, 1 minus 1.5. Upon R. R is what? Minus 10. Got it? Then let us solve it. Here, minus minus cancel. Right. So what will remain? 1 by V, minus minus cancel is plus 1.5 by 20. I'm not solving it, I'll just keep it that way. Then is equal to 1 minus 1.5. How much? Will be minus 0.5 upon minus 10. Minus 0.5 upon minus 10. Obviously minus minus will get cancelled out. That is fine. But if I look at 0.5 by 10, now how do I solve it? I'll just show you a simple trick. Anytime you can convert decimals into fractions, that will be easier because you can do that calculation in your mind. 0.5 is 1 by 2 by 10. 2 will come in the denominator, so it will become 1 by 20. Simple. You can do this calculation in your mind, right, directly. So 1 by V, what did we get? 1 by V plus 1.5 by 20 is equal to 1 by 20. Then I'll take 1.5 by 20 to that side. Let's see what happens. 1 by V will be equal to 1 by 20 minus 1.5 by 20. Look at that carefully. 1.5 by 20 is taken to the other side. It becomes negative. Here it is addition. That side it becomes subtraction. So 1 by 20 minus 1.5 by 20. Then, see, denominators are the same. So you can directly subtract the numerators. It will again come around to be 1 minus 1.5 by 20, which is 1 minus 1.5 minus 0.5 by 20. What is 0.5? 1 by 2 by 20. 2 comes in the denominator. What does it become? 40 minus 1 by 40. So what did we get? We got 1 by V as minus 1 by 40. But is that the answer we need? Is that the answer we need? Minus 1 by 40? No, that is not the answer. Because we need V. We got 1 by V as minus 1 by 40. What we need is V. We have to take the reciprocal. So V is equal to minus 40 centimeter. Units, you can just write them down at the end. So image distance is minus 40 centimeter. That's it. See, once we get the given information, and always draw an image. Image will always be helpful. Draw the image. Once you draw the image, you'll understand the situation. Then you can easily write down the given information. Then substitute, solve, you'll get the answer. So let's come back to the question once. Is the question done? Did we get the answer? Is the answer 40 centimeter? No. Why? Just look at the question at the end of the question. Find the distance of the image. Find the distance of the image from the center of the sphere. That's what we have to do. So here we got V is equal to minus 40. But if this is the sphere, if that is the sphere, here is the object. And this is the principal axis. So from this point from the spherical surface, the image is at 40 centimeters. So if this is the image, this distance is how much? 40 centimeters. That's important. V is equal to minus 40, but from where? From the spherical surface where refraction is taking place. But what do we need? What did they ask us? They asked us the distance from the center of the sphere. What is the radius, everyone? Radius is 10 centimeter. So if we need this distance from center to image, how much will it be? It will be 40 minus 10. 40 minus 10, you can just say 40 minus 10, 30 centimeter. I told you, question is simple, but you have to read that carefully, you have to focus on it. Many interesting points will be hidden. So the answer is what? The answer in this case is option A, 30 centimeter. 30 centimeter. And one more point. Why did I take image to be on the left side of the surface? Because V is equal to minus 40. If it is plus 40, I have to take the other side. Got it? Good. So please practice these questions again. Okay, 2 questions that we have solved. More than enough. If you can understand this, practice this properly, you will be able to do all the other questions automatically. Okay. Let's go into one more simple question, by the way. What is that? A transparent glass sphere. So this is glass. If you look at the image, this is glass. Has a small opaque dot at its center. We can call that as the object. So this is the object. And it is exactly at the center. Does the apparent will mean for the observer, whatever the observer sees, right? So does the apparent position of the dot, that means if someone is looking at it from the outside, what will that someone see? That someone will see the image. So the apparent position of the dot will be nothing but the image, the position of the image. So the question reads, the question means it in this way: does the position of the image appear to be the same as its actual position, that is the position of object, when observed from outside? What do you think? So if there is someone watching it from the outside, if there is someone watching it from the outside, now for this person, for that person, the object and the image, both of them should be formed at the center. Only then that person will see that object and image are at the same point. Is that possible? That's what they're asking. Okay. For that, it's very simple. Let's look at how the refraction will take place. You can obviously use the formula also, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. You'll get the answer. You'll also solve it using that way. But first, just look at the image diagram. If I draw rays from here, this is at the center. And one more interesting point is, at any surface, or at any point on the spherical surface, if at this point, if I want to draw the normal, how will the normal be? How will the normal be? The normal will be a line that passes through center at any point. All these are normal. The normals in the case of a circle or in the case of a sphere pass through the center. That means if I take rays starting from the object, look at how will the rays be? They will be straight lines. And how will the rays be? They will be along the normal. If they are along the normal, what does that mean? That means it is the case of normal incidence. Normal incidence, the rays will directly pass through without any deviation. The rays will directly pass through without any deviation. See here, that's what happens. This is the object. Let's say these are the incident rays, 3 incident rays falling on this surface. But interestingly, at every point, the normal is also along the same line because it passes through the center. It is the case of normal incidence, refracted rays will also be like that. That means, if there is any observer here, and that observer looks at the refracted rays only, then that observer will think, these rays, when I extend them back, they are meeting at this point, refracted rays. That means image also should be formed at the same point. Simple. Okay. So if the object is placed at the center, then the image will also be there itself because of normal incidence of the rays. Okay, simple. Now, sir, can we solve it by using the formula? Yes, we can. But that I will leave as an assignment to you. Okay. So please solve it by yourself. Right. So we solved a few problems. That should take care of the curved surface formula. Okay. So please practice more. Thank you. Thanks a lot.